This is Algebra 2-1, Unit 1-2. Just the intro here. I wanted to go over some review from Algebra 1. First off, when we multiply x squared times x cubed, if you expanded that out, it would be x times x times x times x times x. And we would count up our x's, multiply them all together. There's 1, 2, 3, 4, 5, so that would be x to the fifth. A much simpler way to get that, once you understand the concept, is to simply add your exponents. And then you would get x to the fifth. Be able to expand that out this week and explain to me how it works. Now, in this one kids struggle a little bit more with how it really works. If you've got x times x on the top, x squared, over x times x times x, we know anything over top of itself is equal to 1. So that cancels to be 1, that cancels to be 1. So we have 1 times 1 on top, and we have an x on the bottom. Now, hopefully it makes sense. When we were multiplying, we added the exponents to get the answer. Here, since we're dividing, we can subtract the exponents. 2 minus 3 would equal negative 1. So if we bring this 1 over x up to the top, it actually is x to the negative first. I'm going to have you guys explain negative exponents a lot this week. Okay, x to the first really does just mean there's one x there. If we were to have x squared plus x squared, be careful of this. I'm going to do this to you some this week. X squared plus x squared, well, because they're like terms, you could add them together. There's 1x squared and a 1x squared. If you want, factor the x squared out and you'd have 1 plus 1, which means that you have 2x squared. A couple of different ways to look at that. So ask if you're confused on that one at all. We can talk about it. Now, x cubed plus an x squared, they are not like terms. So you can't factor the x squared out because it isn't a like term just to add them together. I mean, you could factor it out and end up with a binomial, but you really can't just add those two terms together because they're not alike. Okay, so now we're going to play around this week with going from radical to rational exponent forms. Radicals, I know that you've seen. Rational exponent form, I don't know that you've seen that often. So I just want to get it in your notes. This is a to the first power, and it's over the n because n is the root, so it's a to the 1nth. Okay? You can actually take a radical form and always show it as a rational form. Or if it was a to the m, a raised to the m, under the radical n, it could be written as a to the m over n. Now, how do you remember these? Well, I remember them, my funky little brain. The good dog, or the top dog, the one that's favored, gets to go in the house with the guy. So this number in here, this raised, it's always on the top. And the little number on the outside is always on the bottom because he's not as favored as much, or isn't the top dog. That's just a way that I remember. When does it come in handy? Well, if I have a problem like this, and I'm trying to figure out the answer, I could say, well, I know that x squared means 8 squared means 8 times 8, 64, but then I'm a little bit stumped with 64. Yeah, I could break it down and eventually find my sixth root. But using rational exponents, it's much quicker. I go 8 to the 2/3, or I'm sorry, 2/6. Then I reduce that. 2 over 6 is equal to 1/3. And I can actually plug that in the calculator. Make sure you're able to do this week. Plug in 8, then you'll hit the raise button, then parenthesis, and go 1 divided by 3, parenthesis close. And you should end up with the answer 2. Please take your responsibility to do that this week on the calculator, play around with those a little bit. But you can plug those in, what I meant to say, you can plug that into the calculator. If you go to a calculator, typically you can't find a third root or a fifth root or any of that, but you can always raise them to those rational exponent powers and get your answer. Okay, I need you to make sure and get these in your notes. These are a review also of Algebra 1. Product of powers, a to the m times n. A to the n would be a to the m n. You multiply that, or sorry, m plus n. Wow. Just like I just showed you on the last board. A m divided by a to the n would be a m minus n. Product of powers, all we do is we distribute in and we raise each item to that power. So that would be a to the m times b to the m. Now here's the most common error. Kids try to apply this property into this situation. The difference is this has a multiply, this has a plus. You cannot distribute in this case. Would you please highlight that in your notes? I try to emphasize that when we get to this section, but kids still do it. So this time I'm going to try to highlight it here. What this would be, let's say it's squared, then it would mean a plus b times a plus b, and that's when you have to FOIL or box it. You cannot distribute in when you have a plus or a minus in there. Okay, powers of a quotient, all that happens, just like up here, we distribute that in because it's dividing, so it would become a to the n over b to the n. If we have powers of a power, let's say that it's, well, I'll give you specific examples in class because we're going to play games with them. But what you do in this case, you would go a to the m times n. If you have a negative exponent, like I showed you on the first board, anything to the negative comes from the other side of the equation. So if it's a to the negative n, then you can convert that to positive by putting it underneath 1. Now, like on the front board, if it is 1 over, well, actually the front board, it was like this. It was x to the first, and we brought it up to being x to the negative first. If it is a to the negative n down here, flip it over and it will become a to the positive n. In most circumstances, I will be asking you for the answers in positive exponent form. Okay, so here we go. We're going to simplify this. First we go to the rational form. Then I would reduce this fraction so it becomes x, y, I'm sorry, I just made an error. So glad that I got that. Top dog is the one that's in the house. Whew. So now we reduce that. That would become x squared. We go ahead and we simplify one more step, distributing those in, and that would be your final answer. Okay? Remember, the dog inside the house is always on top, otherwise I would have had a critical error there. I do not edit these films. I like to make mistakes in front of you guys, just like I like you and your teams to make mistakes in front of me. Okay, so now this would be written, because we have a radical with no numbers, when there's no number there, it is a 2. It's a square root. That's our most common. When there's no number here, it's a 1. Same thing here. So this one would be written as 1 over 2, top dog. Top dog here is 1 over 3. Now, we have no way to combine those in radical form, but in rational form, we do, because we know we add the exponents. So 1/2 plus 1/3. Going back to pre-algebra skills, in order to add fractions, we need a common denominator. For 2 and 3, common denominator is 6. Because they're both prime, we just get 6 as the common denominator. So 2 times 3 would be 6, so we have to multiply the top by 3. 3 times 2 is 6, so we multiply the top by 2. So we end up getting x to the 3/6 plus 2/6. That will be x to the 5/6. Now it is critical when given a problem in radical form to convert it back to radical form. So we just put the top dog inside the house and the bottom one on the outside. Okay? Next one. Of course we're going to divide here. Again, this would be a 2. That would be a 1, so it's 1/2. This would be 1/4. And in dividing, we subtract our fractions. And I'll be honest, I wouldn't even know the answer in radical form. But in rational form, 1/2 minus 1/4. Our common denominator would be 4, so 2 times 2 is 4. 1 times 2 is 2, so it's 2/4 minus 1/4, which equals 1/4. So x to the 1/4, converting back to radical form, would just be a 4 outside. You can put the 1 inside if you want, you don't have to. Again, remember to write down your questions. In class as a group, we'll be answering those. Now we have a situation where we can put in our 2. You can put in your 1s. You can even convert these if you want to. A to the 1/2, B to the 1/3. Problem is, you can't go any further because our roots are different. You can't combine unlike roots. So this is simplest radical form. Okay, last little problem here. We're just going to apply some of this. This has a 1 on it. Anytime you are in this situation, there's nothing as an exponent, I suggest you put a 1 in there. We're going to distribute this in. So 1 times 2/3 would be 27 to the 2/3. 9 over 1 times 2/3 would equal 18 over 3, which reduces to be 6. Okay, so the only thing we have left to work out is that 27 to the 2/3. You could take a calculator and you could actually just plug it in, 27 raised to the 2/3, and see what it is. But I'd also like you to be able by hand to do it, which means we go 27 cube root squared. I normally will do it that way because it's a little bit easier to get there for me. We could do it the other way. We could square it first, but I like to go small and then go big. Cube root of 27, we break that down. 3 and 9, 3 and 3. And if you remember back to Algebra 1, cube root, and we have 3 3's. Takes 3 to get 1 out, so we know the cube root of 27 is 3. Now we bring in the square. 3 squared is 9. So our final answer is 9x to the 6th. So the question is, what happens if we bring in a negative? How would that change the problem? Hopefully you already have an answer. Just go ahead and pause and put it down in your notes. And now I'll show you what it would be. It would become 27 to the negative 2/3, x to the negative 6th. So we would end up having to work this out, and it would end up being 1 over 9 to let me make sure that that's right. Yes. Yes, because our next step here would be to write these on the bottom. 1 over 27 to the 2/3 and x to the 6th, and when we simplify it would become that. Okay, be ready for some tricky stuff with this. See you in class.